Cool. All right, good morning, good afternoon, good evening, wherever you are in our virtual world. Welcome to the last session of Cloud Gen. My name is Ron Dagdag, and today we'll be talking about men from Mars, women from Venus. Of course, both can code .NET in Jupyter. All right, let's go. So to tell you a little bit of backstory, since tomorrow or since it's close to Valentine's Day, and one of the reasons why I selected the title of my presentation is because of this. My wife and I were both in the work as a software developer, a software engineer. I've been a software engineer since 2000, back in 2000, but I had started doing .NET development back in 2005. Of course, my wife also, she started doing .NET. She's been a .NET developer since 2003. So we've been doing all these .NET stuff since early days. I started as, of course, .NET Framework 2.0. That's when the .NET Framework or the .NET exploded, and I think that's the most stable ones. The .NET Framework, back in 2000, 2003, .NET Framework 1.0 was what my wife got started on. But you can see on this presentation, or in this slide, the main difference. I am a .NET developer doing augmented reality and Internet of Things application. On the other side, even though we're both doing .NET, my wife is working in a large enterprise application in the mortgage industry or in loan industry. So I use a lot of .NET Core, and of course, my wife is maintaining a large enterprise application is still on .NET Framework, and of course, .NET 5 is going to help us migrate a lot of that. And I work part of a startup, so that means I'm writing brand new software. And of course, my wife, Leodette, she's been doing a lot of .NET that makes a lot of money, right? So two different worlds. And that I feel like, that we're both living in different worlds, even though they're both .NET. Of course, I am a Microsoft MVP. My wife actually got her certification in Azure as an Azure DevOps engineer, so which she recently got last year. So that I think it's great. But so we both live in the same .NET solar system. I feel like we're both two different worlds, although they're both .NET. And then lately, in the past few years, we kept hearing another world out there, the world of Jupyter and data science. And I heard that there's a bunch of Pythonistas that live there. So, and of course, you would agree, they have a mug. So if you're interested in becoming a Pythonista, we might as well get this mug, right? So today, I will be focusing on how you can do .NET in Jupyter Notebooks. And what is Jupyter? And what is .NET Interactive? How do you run .NET in Jupyter Notebooks? I am going to demo it in a Raspberry Pi, and hopefully we'll land in Jupyter. That's the goal. All right, so what is Jupyter Notebooks? Jupyter project is an open source web application since since 2005. It's focused on creating and allowing us to share documents that contain live code, equations, visualizations, narrative text. And you'll see the difference later on how you would use Jupyter. It's geared towards interactive data science and scientific computing. Fun fact, the word Jupyter Notebooks is actually a combination of Julia, Python, and R, which are the first kernels or first capabilities that it was able to, it used to be called IPython notebooks, and it's released under modified BSD license. Guys, if you have any questions, feel free to place them in the chat. We can monitor them, and feel free to ask questions. So .NET Interactive. What is .NET Interactive? .NET Interactive is .NET into interactive experiences. So it's not just limited to Jupyter Notebooks, it's also Interact and also Visual Studio Code. If you don't know, the Visual Studio Code can actually open Python notebooks now, and of course it has some extensions that specifically you can use it in Jupyter in Visual Studio Code. So it's really focused on how you can share code, explore data, and learn across your application. And it's legit because they have these icon. I like their I like their logo. You know, all the .NET .NET logo over there. So see that cartoon going not just global but also universal, out of this world. Okay. .NET in Jupyter Notebooks is geared towards being able to run .NET in Jupyter Notebooks, where you have currently we have Python and R, and of course all these different kernels. A kernel is it's a way to run the application in two different languages. You can mix and match. That's what's awesome about it. So there's the C#, the .NET in Jupyter Notebooks allows you to have C#, F#. Of course, I was surprised also you can even have PowerShell commands in Jupyter Notebooks now. I thought that was amazing. And I'll demo a little bit of what this ls magic or this magic commands, and it kind of gives us the different commands that you can use inside that kernel. And then of course the Pocket View allows you to display HTML, and I'll demo that later on inside the Jupyter Notebooks. And of course it adds all these different libraries too, XPlot, data visualization. It's more focused on data visualization, where you can print text, graphs, HTML, SVG, or if you want charts in your application, that would be a way to go. Cool. All right, Azure Data Studio. The easiest way, not just the easy way, but what I'm saying is that if you want to experiment with this, I would recommend trying out Azure Data Studio. It has actually a way to add Jupyter Notebooks now, and .NET Interactive. There's a way you can install .NET Interactive in Data Studio. So it looks something like this, where you have, once you install it, it's Azure Data Studio is available on GitHub, and just download that package. But it allows you to have, create a new notebook, and you can, it doesn't have C# in here, but these are all the different kernels that you can identify. You can do SQL, PySpark, Python. I've noticed that if you click on, let's see if I, in SQL, see how if I click on something else, I don't know, it might be a bug, but it allows you to have C#, F#, and PowerShell if you have .NET Interactive installed in your machine. So, and then you can select that, and then you can write notebooks. Cool. Visual Studio Code. There's also a way to do that. Let me see how I can show you. But there's a .NET Interactive notebook extension, and you can also convert to from existing Jupyter Notebook to .NET Interactive notebook. But let me see if I can get my Visual Studio Interactive here. So there's instructions on how you would do it, how you would install it in your machine. So make sure that you have to use because it's early preview, right? So I would suggest you would use the Visual Studio Code Insiders Edition and select the interactive notebook. Install Visual Studio Code, make sure you have .NET 5, and then install this extension from the marketplace. And that right there would install .NET Interactive locally in your machine once you have .NET. And then you can start creating applications. So you can let's see, you can create a new interactive blank notebook here. And it will create a new one for you. See how it says here the kernel is C#, and then you can start typing, right? Console.writeline. So what I like about this is this autocomplete. Hello world. See? And then you can notice how you would run a program in Python notebook. I thought it was wild because I was like looking for the main, what do you call these, that main application or the main class, right? And there's no main class. You just write the command and it would execute it for you. So I thought that was very interesting. All right, let's go back to the presentation. All right. So you also use it for Visual Studio Code. So how does it work? Pretty much a high level, what you call architecture of it. Whenever we talk about kernels, these are pretty much the kernel side, right? Where your application runs, each one of those applications, each one of those notebooks maps to a kernel instance of maybe it's a C#, F# or PowerShell, or all the different Python, all the different execution or language services. And then this is the applications, which is your front end part. So you can have it in Visual Studio Code, Spark.NET, right? Azure Notebooks, Azure Data Studio, Jupyter. You can have it in Jupyter, Jupyter Lab, Interact. You can even create a bot that would connect to .NET Interactive and then execute here and then goes back and give you the results. So it's like a chat application running some application in the background. So the way we would do it, it would pass the command. Each one of the lines would, in your notebook, would get passed to a protocol or transport protocol, and then would get executed if it needs to create an instance in the back end. It creates an instance, and then any result of that program would pipe back so that you can see the results. I thought that was pretty cool. And .NET Interactive allows you to have also other, kernels in the future. So it's, if there's a new language that can be expanded into, you can create your own language and connect it through .NET Interactive. So that's cool. All right, so I'm going to focus on how you would run this on a Raspberry Pi. The reason why I wanted to run it on a Raspberry Pi, because as a .NET developer, we're focused on running it on the Windows machine, on a PC, right? And then running it in a Windows machine and the PC, and also, running it locally. So what if, let's try it on this small form factor device, right? A Raspberry Pi, which is running on an ARM64. That means it's not an AMD chip, or it's not an Intel type or AMD. It is actually, an ARM processor, right? And we know that ARM processors, .NET runs on ARM processors now, and with the smaller form factor. And of course, I want to tinker with Internet of Things, and we know that .NET has a way you can connect it to Internet of Things and be able to do that. So let's start. So if you're not familiar with Raspberry Pi, it's actually running on Linux. It's not running on Windows this time. So I installed the Raspbian on that machine, which was running on Linux. So .NET also runs on Linux. I thought it was totally different world from what we're used to, and that's what I'm trying to show here. And of course, to make it easier for me to kind of connect to different sensors, there is an add-on or a hat. They call it a hat, which connects on top of your Raspberry Pi that can give you sensor data, right? In this case, there's an LED, there's buttons, there's also sensors like temperature and all that, so it makes it easier for us to be able to collect data from it. How do you install it in Raspberry Pi? There is a, there's a, on .NET Interactive, there's a setup script that actually would install .NET on that machine, would install Jupyter Notebook on that machine, and it would install .NET Interactive and connect them together, and be able to run Jupyter Notebook. So pretty much a few steps in how you would do it, and then you're ready to go, pretty much. If you're interested in getting, my presentation material, feel free. I will post this later on, but for now I'll concentrate on the demo. Any questions so far? Feel free to write them in the chat if you do. Okay, let me try to do my setup real quick. So this is my Raspberry Pi, and it has a Raspberry Pi hat on it. I'll just make sure the video is running. Okay, so let me try to get to my, all right, here. So after I installed Raspberry Pi on that machine, .NET, Jupyter, and .NET Interactive on that machine, when I start, it allows me to, on my browser, on my computer, right? I was able to, if I know the IP address of my Raspberry Pi, I try to connect to it, and it will get me to this Jupyter Lab. Jupyter Lab, what's the difference between Jupyter Lab and Jupyter Notebook? Jupyter Lab allows me to have this file management, so where I can see, okay, these are all the files that are on that machine, right? And then I can create file new notebook, and I can create a new notebook. And then I specify here, okay, I want to do a C# notebook, and then I click select, and then now it has the C# kernel, and then I can start writing C# code in here. I like it here too, like if you've done any development on these Raspberry Pi, you can actually connect from here and create a terminal, right? So terminal allows me to just, instead of SSH to that machine, I can just use these browser-based application to be able to connect to my console application. I thought that was amazing, and I can just connect it easily from the browser. Think about it, it's all running in the browser. Okay, so let's start. I have these demo. First things first, it allows us to create these markdowns. If you want to add documentation to your code, it just makes it easier to create, to add the new cell and write a markup language. And then when you click play, it renders it, right? Or you do Shift Enter, and it would run that cell. So it's made up of these different cells, and as you run it, so you see, like in this this way. So like in this is code, right? Specifies as code. You can actually add another one, right? That way. And every time you would run, so in this case, I would say console.writeLine, because I know it's C#. Hello world. Okay. And then I hit Shift Enter. See how it gives me a number right here? That means how many lines of code or how many cells have I run since, and then it executes this to the background kernel or backend kernel, and then the result would pipe back below that command. And then, just think about it kind of like a CLI, but you're doing it remotely. Not necessarily, in this case, it's remotely because we're actually running this code in Raspberry Pi, but we have our interface in the browser, right? So we can run this lsmagic. lsmagic allows me to know what kernel is available, so that I can run. I can do C#, F#, PowerShell. You can do JavaScript. You can do HTML, and all this different one. And then in C# kernel, you can specify kind of like the shared variables. Activate ASP.NET Core. I haven't really tried this one. I thought this would be interesting to see. I'll try that next later. So you can also run F#. You can run PowerShell commands, and then JavaScript commands. All right. So if you want to run F# code, since this is C#, you can specify, hey, I want to run F#. This is hello world in F#. And then I assign 2 variables here. And once I execute it, right, it gives me the result. And then if I want to share that variable X that I assigned into my C# kernel, I can do this, and then it would say, okay, X is equals to 10 because I just want to display it. Since I did not share Y, my C# kernel does not know it. And of course, it'll give me errors. Yeah, it does not know, even though the F# kernel was assigned that value to kernel instance. So X plus 2, right? That's how you would specify commands. And then this whos allows me to see, what are the shared. So X is shared, and of course all the rest of them too, which we'll deal with it later. And if I want to list all my PowerShell commands, I can do that too, and to specify PowerShell. You can create, a notebook, right? A new notebook, and you can say, hey, I want PowerShell commands. And this is the interesting part. You can run PowerShell inside Raspberry Pi on a Linux box. I was so amazed by that. It's like, PowerShell is not just limited to Windows now. That's amazing. So if you're familiar with PowerShell and you've worked with it, you can actually run it on Linux. So these are all the different commands available to PowerShell on Linux. There's a bunch of them. Okay, so in this one, the next one is I want to get the NuGet packages, right? And NuGet packages, this is how you would include the NuGet packages. You specify where it is on NuGet, right? In this case, I want to import system.device.gpio, and this one allows me to read GPIO data, or general purpose input-output data, into my Raspberry Pi. And this IoT device bindings allows me to be able to connect to my Sense hat, which is the one that I have connected to my Raspberry Pi. This UnitsNet allows me to do conversions, or from centigrade or Celsius and Fahrenheit. So what this one is doing, it's actually downloading those NuGet packages. I think I already downloaded it, that's why I didn't display it there. This one allows, this pocket view command allows me to create an HTML link, right? So I want the word presentation to be bold, and I want to put in an href with an anchor link, and do a span. So when I run it, see how it doesn't do anything. So if I want to display it properly, I'll display pocket view. Oh, of course I misspelled it. There you go. There you go. See, there's a presentation with the link. And if you want to click on that, it goes to my GitHub. So it works. So of course you can do it this way. So in this case, I want to display this some HTML and assign it to a variable. There you go. There's sensor data. And then what I want to do here, so for some reason it was giving me an error. That's why you can add this pragma warning. It's not really an error, but it's just a warning. So if I want to remove some warning whenever it runs, you can do that and specify it. So I'm here, I want to use IoT.device.sensor_hat, and what I want to do here is I want to be able to read, right, from the sense hat, right, the temperature, degrees in Fahrenheit, and I want to add it to my list. But my list is a tuple that has index, which is, how many times I ran, and then the corresponding value. So I just want to add it there, and as it runs, it would update this sensor data, would change into whatever temperature it got. So await, I'm going to call this read temperature. I'm going to call it 10 times, right? See, of course, if I run this, wait, it'll give me an error because I have not run this. I guess it wouldn't give me an error. See, so now see how it's running. See how it's updating that value. So that's what's going on. So now I have a list of temperatures, right? Because of that, and there's 10 items on it. Okay, now I want to use this xplot. So xplot allows me to be able to, this one right here just lists all the values from 0 to 9, right? All the values that I got from my Raspberry Pi. And this one, the xplot, what allows me to create this graph that's scatter to be able to plot that graph, getting the values and also the temperature of the index. So I want to graph it. Sometimes it's better when you run and you want to say display chart. That. And there you go. That right there. I was able to create a chart and would display the values that I got from my Raspberry Pi, sense hat, temperature readings, and then create a graph around it just by doing a few commands. And when think about it, if you're doing this on WinForms, and you have to think about all the different to display it correctly, right? The different things you have to do in order to display the chart properly. And this one is just a few commands. You're able to do that, and it already has some interactive parts in it, like be able to select which point, and you can zoom in and zoom out. You can there's pan, be able to view more data, more information. Cool. All right. So in this next one, what I want to do here is I want to get the same temperature sensor, right? And I want to use asynchronous stream. Asynchronous streams allows me to be able to kind of do a for each, and then a yield return. So as I receive that data, I want to return it back automatically, or from this asynchronous command, and then wait for 1 second and read it again, wait for 1 second, read it again. And as it receives it, then I can start processing that data. So these are asynchronous streams. And then Microsoft that data analysis, I want to get that NuGet package and then include it in my application. See right here, it's downloading that NuGet package, Microsoft that data analysis, and then apply it to my kernel. After it's done, and see how it tells you, hey, it's done. Then you can move on to the next command. So in this one is I want to use these primitive data frame columns. So I want to work with data frames now. So data frames allows me to be able to, and I'll demo that. It allows me to be able to kind of create instead of a table, kind of like a table in a way. But I want this to have these columns, date, times, and Fahrenheit, and then see this await for each, calling an asynchronous data stream. I will call it 15 times. And then as I receive the data, I want to append it to my date times column, and then Fahrenheit, whatever that result is, get the timestamp. So I know at that point in time, I added it to these date time column, to this. So now it's doing it. As it receives that data, it adds it to my columns. So after it's done, I've done it 15 times. Okay, see how we know it's done. It's that value. So we want to create a data frame, 2 columns, right? In this case, I want date, times, and Fahrenheit. Okay, let's see if that one works. So it created a new instance of a data frame, adding 2 columns in it, and I want to display my data frame. There you go. It's like, why is it so garbled? I can't understand that, but it kind of maps it magically. So this one allows me to, I copy and paste this somewhere to display, in this case, the first 5 items on my data frame, even though I have 15 items in it, and I want to display it properly so that it'll show correctly. So now if I run this, and display df, what this program did was to register kind of like a hook that every time you would run it, it would create and display it properly. So it picks up the first 5 items on my list, kind of formatted in HTML, make it look pretty, and so it looks like that. So the first item on my list was the time and then the value. Okay, so in this one, I want to get the first 2 rows on my data frame. And if I want to count the number of rows, df.rows.count, right? And there you go. I got 15 items on it. I'm going to specify 15. But this one, I want to create a new column called Celsius. Okay. And this one, I want 15 items on it, since I'm going to have 15 items on my the 15 rows, right? So I want to specify, I'll create a new data frame column with 15 rows in it. And I call that column Celsius. And here I want to clone my data frame. I want to create a new one, a copy of it, and insert on the last column of that new data frame Celsius column, and then display it. So right there and there, I got date times, Fahrenheit and I added a new Celsius column, but of course it's not initialized. That's why it has null in it. Okay, and it's double, but it's not initialized, so that's why it's null. If I want to learn more about my data frame, I can do it this way and say, okay, how many items do we have in date times? How many items do we have in Fahrenheit? This one, Celsius column, it's not initialized, so that's why it's 0 there, even though it's specified that we have 15 items. And on here, I want to fill the nulls. I want to fill in on the Celsius column, fill the null values and initialize them to 0. So now I have a column, they're all initialized to 0. So imagine if you have 1,000 items on it, or a million items, it'll do that automatically. This one, it allows me to give information about my data frame. And if I want to get the first row, I can do it this way, right? So in this one, now my row 0 have these values, right? Okay, moving forward. If you have questions, feel free to place them in the chat. I think I'm gonna move it a little bit faster because we might be running out of time. I got maybe 15 minutes to finish, 15-20 minutes. So this one, I want to convert the Celsius column from from the Fahrenheit column, fill it to the Celsius column by doing these Fahrenheit. But it's just this one reminds me of Excel. When you have these formulas and you specify the formula for that, cell or the column, and then there you go. So it converted Fahrenheit to Celsius and fill in that Celsius column. And then if I want to calculate the mean, which of that Celsius column, I can specify a mean, and there you go. 30 degrees Celsius. And if I want to plot it, this allows me to be able to specify date times column and Celsius. And there you go. That's my reading for the past few minutes and displayed in a chart. It's getting cold in here, but not as cold as any other places. Okay. So in this next one, I want to be able to read the temperature data, okay, and wait half a second, read it again, right, and then do it 10 times. Okay, so of course I'm going to call that later on, this read temp data. So I just specified it in this temp data. Here, what I want to do is to be able to run a JavaScript application in my Jupyter notebook, right? And this JavaScript application would import. This is all running in the browser side in this point, right? It's not running on the JavaScript or a Node kernel. It's actually going to run locally on the browser, and this one would import D3.js so that I can create a graph and then to display it. So these are some, pretty much you're working with SVG graphs at this point, translating it, creating a scalar. And then the magic that I wanted to show you guys is here. What this one is doing is like every few seconds, it has this .NET interactive.c# .get variable. So my C# kernel, I want to get the value on that one, right? Which I specify in this variable name, variable name pass into this function, right? What variable name it needs to look at to my C# kernel. and then pass that along here and display it properly. Okay, and then it would update that rendering. Okay, let me see how it goes. Let me try to update that JavaScript application if I want to create an HTML now, and if I want to add this HTML tag called SVG, this is where my application is going to display this data plot ID, and with this size, right, this is HTML, and then I want to be able to say, okay, display it on this HTML tag data plot, call this JavaScript application notebook scope.plot, and then pass in this temp data to it so that it'll display it properly. So it created my chart, but it might not be going to display it properly because the values that we have is about 87. But we'll see how. Let's run it maybe 5 times first and read the temperature data. So I'm getting about 86 items, or 86 to 87. It's not going to be in my graph because that one is 92 to like 94 or something. So let me try to modify this a little bit. It's just a range and what goes to my graph. So it's maybe 86 to 88. Let's try that. Let's run it again and then update my my plot. So now see how it's run. So I want to run this read temperature data since everything's hooked up together with this. So once I run this read temp data, it would read the data from my sensor, assign it to this variable that this JavaScript program in the front end in my browser is listening into, and then it would update my graph. So I want to call it maybe 10 times. So what it's doing is it looks at the last 10 items on my graph, right, on my list, and it would display it properly. And then after 10 items, it would remove it because I think that's how I specified it on my. Let's go back there just for clarity real quick. So with this one, read temp data, what it's doing is it only keeps the last 11 items, and then anything beyond 11 items, it would just kick them out, right? I don't want it. And it would replay, it would just continuously receive that data. And then, of course, this temp data that we pass into our JavaScript would create that graph or display that graph properly. Okay, let's go back to here. And let's rerun it again just to see it. So it's kind of like a live interactive one. I want to run it 15 times. So as it receives the data, it's updating my graph. See how it's changing the size, as it receives it, the latest one is always going to be on the right, and it's going to build up that graph. So now after running it multiple times, my temp data only has 11 items, even though I run it, a few times already. It automatically adds it to that list. If I want to see my list, right? Yeah, that my temp data only has these items, and it has 11 items all the time, which is the last 11 items. Cool. That makes sense? I think it's cool. What just happened, right? In the past few minutes that we've been together, right? I was able to install and run .NET on a Raspberry Pi, which is on the Linux box, which is on a small form factor. It's not an Intel device. It's an ARM processor, and then be able to have Jupyter Notebook installed on that machine and run .NET in our browser, right? It runs on that Raspberry Pi in our browser as our front end to be able to send commands back and forth and be able to see a graph, be able to plot the graph from that data set, and then be able to send commands. So on this next one, I want to do is I want to be able to say if that item, is more than a certain, if the temperature is more than a certain amount of degrees, I want to be able to control the LED matrix on my box and change it to color red, just to make sure that you know, it's not running on my machine, it's actually running on this Raspberry Pi, right? So this is a video stream of my Raspberry Pi, and I want to display this properly. So let's go back there. I'm gonna run this one right here where it reads the temperature, and if it's certain maximum temperature, then it would change that color to red. So let me see. Read temp condition. I'm gonna call it one time, and let's see the maximum temperature. Maybe it's 100. Of course, it's not gonna, change that light to red because it's below that condition. So if I wanted to 87.50, let's see, let's run it again. Of course, now it's 89. Let me see if I can run it multiple times. So I want to change that to black again, turn it off. I want to do it maybe 90, 91. Let's see how it goes. Of course, it's not going to read 91. I'm going to read it maybe 5 times, see if it's going to reach. Of course, it's not going to reach that high. 88. Yeah, I'm just trying to tune in at this point because I wanted to kind of see if it's going to reach that value. I may need, let's see, 87.5. Of course, it's not going to reach it now because it says 187.15. Anyway, you get the idea, right? So it's going to reach at a certain point. In this case, I want to do, 19. Of course, it's not. It's temperature readings. It changes that much. I can always put 87.1, and of course, it's gonna turn it on because of that, and then turn it off because it's too bright and hurts my eyes. And there you go. Okay, cool. What happened there? Let's go back to the presentation. Right there. So if you are interested in learning more about my presentation, for some reason my screen is about my presentation material, feel free to log in or to reach out and get my GitHub account. And if there are no other questions, if there are any questions, feel free to place them in the chat. And thank you for your time. If you want to contact me through social, on GitHub's Ron Dagdag, pretty much everywhere. And if you want to learn more about me, I'm a lead software engineer at Spacey. I've been a Microsoft MVP for the fourth time now, 4th year, and interested in learning more about my projects, go to dagdag.net. And I appreciate your time geeking out with me about Jupyter notebooks, .NET code, Visual Studio Code, Data Studio, right? Raspberry Pi, .NET IoT, all these different technologies. That I think it's really awesome, and I appreciate your time. And any questions so far? Feel free to place them in the chat if you have any questions. I think it's cool. I think what happened here, I think it's very interesting because we were, recapping and going back. You can run .NET Interactive on a small form factor devices now. And of course, it's not just limited that, all these different .NET Interactive can run not just on Visual Studio Code, you can run it on, and .NET Interactive also is open source. So if you were into open source products and be able to contribute, that would be great. So thank you for your time. If there are no other questions. Cool. All right. Cool. All right. Stop sharing.